welcome back to Pepcoding. So the question which we will discuss today is called UTF-8 Encoding. So first let me explain the question to you and then we will talk about the solution. So basically you have been given an array of numbers, okay, and you have to check whether the binary representation of these numbers gives us a sequence which is valid according to the UTF-8 encoding. So we have a certain set of rules. The rules which you have to follow is that the numbers should be 1 to 4 bytes long. That is the sequence which you use will be 1 to 4 byte long. And in this also we have rules for each of these. That is, if it is 1 byte long, then the most significant bit should be 0. Rest 7 bits can be anything. If it is 2 byte long, then the most significant byte should have 110 in the beginning and rest 5 bits can be anything. And for the second byte, the first 2 bits should be 10 and the rest 6 can be anything. Similarly, when we have 3 bytes, then we should have 1110 as the former 4 bytes in the most significant byte, former 4 bits in the most significant byte, and rest 4 bits can be anything. And for the second byte, it should start from 10 and anything. And for the third byte also, it should start from 10 and rest can be anything. For a 4 byte long set, over here in the most significant byte, the first 5 bits will be 11, 11 and 0. Rest 3 can be anything. Then for the remaining 3 bytes, it should start from 10 and the rest of the bits can be anything in each of those. Okay. So now we need to work with this. Okay. Now let's suppose I'll take an example. I'll say 0101 and then 110 11 0 10 and here I have 10 11 0 0 10. Okay. So over here the first one is starting from 0. That means it should be 1 byte long. It is independent of any other number in the entire sequence. Then I have one which is starting from 110. That means it should be 2 byte long. So the next bit should have 10. Okay. Now over here, this has 110, this has 10. So this is a 2 byte long UTF encoding and it is correct. So these both are valid. So overall we will return valid only. Okay. Now let us take a case where over here we had 11. Okay. I'll just write this again. We had 11 over here. So I checked that this was 110 and over here I needed 10 but I am getting 11. So that means that this will be wrong. So it will return invalid to me. It can neither be independent and coming with any other number, it will give me wrong sequence only. So even though this is valid, but since this is returning invalid to me, that means I'll return invalid as a whole. Now let us try this same concept with a complete array of elements of numbers and I'll just create that array and I'll show you the example. Okay. Okay. So over here we have this array. So let us check for these. I saw that over here I have 1110. So that means we are working for 3 byte. Now when we are working for 3 byte, I need the next two elements to start from 10. I'll check these two. It is starting from 10. So this will hold true. Then the next one is 110. That means it is working for 2 byte. So the next number should start from 10. It is starting from 10. So this is valid. The next one is having 4 ones and a 0. That means it is working for 4 bytes. So I should have 3 other numbers with 10, 10 and 10. So these 3 have 10, 10 and 10. So this is valid. Now let us create a situation. Let us imagine a situation where some of this can turn out to be false. Let's say that over here, I will say over here, I had 10. Now this is creating a valid set. But now over here I have 10, which is not correct for any of these, right? So that means that this will give me false, right? It will return false. So I will simply return false from here. I will not even check for the others. Okay. So now let us try to code this. I'll just make this full screen. Alright, so I'll move in the array. So I'll just use a for each loop. Now we have conditions, right? The first condition which we are working with is that it is 1 byte long. Second is 2 byte long. So the most significant byte will have 110. For 3 byte long, most significant byte will have 1110. And for 4 bytes, the most significant byte will have 4 times 1 and a 0. So first I'll work with these. Okay. So when I'm working with these, we have been given a constraint where the number which we will be having is 0 to 255 only. That means even though integers are 4 byte long, and that means we have 32 bits, we will only consider the last 8 bits and the remaining 24 will be ignored. Okay, so we don't have to work with them. We are only working with these 8 bits for any number. Okay, so when we are working with a number which is 1 byte long, that means it should have 0 in the beginning. So I have 0, then 5, 6, 7, 7 random bits. I want to check this, so I need to bring it over here, right? So I have to shift it by how many places? 7 places, right? So I will create a condition over here that if I shift my value by 7 bytes and end up getting 0 in binary, then I'll do something with it. Else if the second condition would be for 2 byte long, so I should have 110, right? And that means that over here I should have 1, 2, 3 and 4 bits randomly. So I need to shift 110 by 4 bits, right? So that I can get 110 at the end. So I will shift my value by 4. Okay. So over here, wait 1 second, I'll just recheck this. I think this is wrong. If I have 110, right, we have 5 separate bits and I want 110 at the end over here. So I want to shift this by 5. My bad, that was wrong. It does not have to be shifted by 4. It will be shifted by 5 in the case of 110. Why? Because we have 8 bits. 110 takes up 3 bits. So there are 5 remaining bits and those we have to bring at the back so that 110 can come to this side, right? So we will shift by 5. So val will be shifted by 5. And if I ended up getting 0 bit 110, then the 2 byte condition will be executed. Else if I'm working with 3 byte now, so what will happen? I have 110 and then 4 bytes. I want to bring 110 over here, so I have to shift by 4 bits, right? So I'll shift val by 4 bits, and if I end up getting 0b1110, then I have 3 bytes. Else if I have 4 bytes, then that means I should have 4 times 1 and a 0 and 3 other bytes, 3 other bits. So I have to bring this over here, so I have to shift by 3. So I'll shift val by 3. And if I end up getting 0b1111 and 0, then I'll work with this condition. And if it is not either of these, that means it is wrong. So I will simply give cout false and I will return from here. Okay. Now see, when I'm working with these conditions, for 1 byte, I have started from 0 and then 7 bits are different and there are no remaining bytes, right? With 2 bytes, I have 110 in the most significant one and then 1 byte after that which we have to check. Then for 3 bytes, we have 1110 and for the next 2 bytes I have to check, so remaining bytes will be 2. Then for 4 byte, I have 11110 for the most significant byte and then 3 bytes which we have to check, right? So I will take a variable over here, remaining byte, which will start from 0. So for this one, that is for 1 byte, remaining bytes is 0. For 2 bytes, remaining byte will be 1. For 3 bytes, remaining byte will be 2. And for 4 bytes, remaining byte will be 3. Okay. Now another thing which we have to focus on is that we have to work on these, that is for the most significant ones, only in case where the value of remaining bytes is 0, right? In the beginning, value of remaining bytes is 0 only, no? So when we are checking for the most significant bytes, the value of remaining bytes should be 0. Only then it will work for most significant. If it is anywhere greater than 0, that means we are working for the remaining bytes. So we will make sure to add that condition, that if remaining bytes is equal to 0, only then we will work with this. I think I misplaced the bracket. Okay, so this whole thing will be shifted in this condition. Okay, then after this, another condition which comes for us is that if I have certain remaining bytes, right, that is only the second condition which we need to work with. So if I have remaining bytes, for example over here, I'll just change the color. So this has to be 1 0 1 0 1 0 1 0 1 0 1 0. That means for all of these bytes, I don't have to check separately for each remaining byte, right? For every remaining byte, I will have the first 2 bits as 1 0 only. So out of 8 bits, if I have first 2 as 1 0, then the next 6 can be anything. I want to bring this over here so that I can check it. So I will shift it by 6. So else I will check that if I shift my val by 6 and I end up getting 0 be 1 0, then in that case, what should I do? I am moving from this byte to the, okay, let's not work with this one. Let's work with this one. I have over here remaining byte as 2. When I check this, remaining byte will end up being 1 only, no? Then I'll come here, check over here, remaining byte will become 0. So it will directly go for the next sequence now, right? Similarly, when we are working with 2 byte, remaining byte is 1 only. After checking this, it will become 0. So we will not work with it. We will go back to this condition, the above condition. Here, it will be first 3, then it will decrease and become 2, then it will decrease and become 1 for this. And for next one, it will be 0, so it will not check. So over here, we will decrease remaining byte by 1, right? In case remaining byte is greater than 0 and the after shifting the value which we get is not 1 0, the 2 bits are not 1 0, we will simply print false and return from there. Okay, now there can also be a condition that when you've checked your complete array, when you're completing your array over here, I will get a number like 1 1 0 1 0 0 1 2 3 4 5 6 7 8. Okay, this was a group, this was a group, and this was a group. Now for this I see that I have 1 1 0, so I need another number, right, which should start from 1 0. But over here I am not getting that number, I have only this one. So there can be a condition where I have remaining bytes, okay, but even then it is not forming a group. In the end I have only one remaining byte. So I will check that if remaining byte is greater than 0, I will simply print false, okay, and I will return. Otherwise, even after all this, if we are working perfectly fine, then we will print true and we will return. Okay, so now let's try to run this code and we will submit this. So it is passing the test cases. So we discussed about the question UTF-8 encoding. I hope you understood the question as well as solution. So thank you for watching the video. We will see each other the next time. Till then, please like, share and subscribe to the channel. Thank you.